Hello dear students, good morning all of you. I hope you all are safe and studying really good. See, in previous video we have started solving your practice set 2.3 of chapter real numbers. In that video we have solved question number first. Now we will start with question number 2. Okay, what is question 2? State which of the following are surds. Okay, when we called the numbers as a surds, we called it surd if they are positive rational numbers and whole the number is an irrational number. Okay, then only we can call it as a surd. See here they have given us total 6 numbers and they asked her whether it is a surd or not. See, under root of 3 under root of 51 is a surd because 51 is a positive rational number. We know that 51 is positive rational number and 3 is a positive integer. It is positive, you know, integer must be positive, then it will be the rational number, and positive integer greater than 1. Obviously it is positive integer, then it must be greater than 1. Okay, the integers less than 1 are negative integers, they cannot be positive. So it is a 3 is a positive integer greater than 1. Therefore, and 3 under root of 51 is an irrational. So 3 under root of 51 is a surd. So first one is a surd. We will move towards the second. Why it is a surd? See, 51 is a positive rational number. Okay, then 3 is what? 3 is positive integer greater than 1 and whole this number is irrational. Therefore, we can call this as a surd. Okay. Next one, 4 under root of 16 is not a surd. Why it is not a surd? Because see, if under root of 16 and 4, then we can write it as 16 into raised to power 1 upon 4. Then 16 can be written as 1 raised to power 4. Okay, so that 4 will get cancelled. Okay, raised to power, and we will get just 2, and 2 is not an irrational number, 2 is the rational number. If it is not irrational number, it cannot be surd. Okay, surd is the only number which are irrational. 2 is the number which is a rational number. 2 is not an irrational number. Therefore, this number is not a surd. Next, we will move towards the third one. 5 under root of 81 is a surd. Why it is a surd? Because 81 is a positive rational number and 5 is a positive integer. Okay, 5 is a positive integer greater than 1. Therefore, and this whole number is irrational. Therefore, we can call it as a surd. Okay. Why it is a surd? Because whole the number is irrational, whereas 81 is a positive rational number and 5 is positive integer which is greater than 1. Therefore, it is called as surd. Now, 4th, 5th and 6th example I have just written it is a surd or not. You have to justify, you have to write like this. If it is a surd, you will write like this, and if it is not, you will prove like this too. Okay. Under root of 556 is not a surd. Next one, 5th example is 3 under root of 64. It is also not a surd. And here 6th example is under root of 22 upon 7, which is a surd. You have to justify for all these 3 like this I have written on the board. See the first example, 3 under root of 51 is a surd because 51 is an positive rational number, whereas 3 is the positive integer which is greater than 1, and this whole number is a irrational number. It is irrational. Therefore, though we can call it as a surd. But in this case, you can see 4 under root of 16. 16 is it is not a surd because we can write it as 16 into raised to power 1 upon 4. Okay, but 16 can be written as 2 raised to power 4 upon 1 upon 4. So it will be just 2, whereas we all know that 2 is a rational number. 2 is, if it is not an irrational number, how we can call it as a surd? No, we can't call it as a surd. Therefore, this number is not a surd. Now this, for this we can write the justification like the first one, like 81 is a positive rational number, whereas 5 is a positive integer which is greater than 1, and this whole number is a irrational number. If it is irrational, then we can call it as a surd. Therefore this number is a surd. Now similarly we have to explain for this. You will write this like this, with the justification, that is under root of 256 is not a surd. I have told you it is surd or a not. 3 under root of 64 is not a surd, and here under root of 22 upon 7 is a surd. Okay, this is your question number 2 from practice set 2.3. If you want it, you can take the screenshot and write down it in your notebook. See, question number 3 from your practice set 2.3. Pay attention here. Classify the pairs into like surds and unlike surds. They have given us some pairs of surds and we have to classify those pairs into like surds and unlike surds. The question comes, what is like surds? I have already told you. If the order and radicands are same, then surds are called as like surds. Then what we have to check? We have to check the order of the surd and radicand of the surd. If there are pairs of a surd, it means there are two surds. If we check the order and radicands of a surds, they are equal, they are same, then it is called as like surds. If they are not same, then it is unlike surds. We can classify it very simply, but while looking at these numbers, we can't classify them. We have to further solve it, and then by simplifying the surds, we will come to know the order and radicands of the surds. See here, the given surds are under root of 52 and 5 under root of 13. Okay, here we can say the order of these two surds are same, that is 2. Nothing is 2 because we are learning the surds of order 2. So here will be 2 and here will be 2. The order is same. Now what we have to check, either the radicands are the same. If they are same, then it will be like surd. Okay, 52 can be further classified as 4 into 13. Okay, we are factorizing it in simply. You can write it as under root of 4 into under root of 13. If we remove the root sign, or we will take 4 outside the root, it will become 2 under root of 13. So you can see here 5 under root of 13 and 2 under root of 13. The order is same, that is 2, and radicands are also same, that is root 13 and root 13. Therefore this is like surd. Okay, you have to justify here the order of a given two surds is same and radicands are also same, that is root 13. Therefore this surd is a like surd. You have to write it in a word what the order of given two surds is same, that is root 2, and radicands are also equal, that is root under root of 13. Therefore this surd, these two pairs of surd, this pair of surd is a like surd. Now we will move towards the second example. It is under root of 68 and 5 under root of 3. We have to further simplify this. Therefore we can get either the radicands are the same. We can see order are same, here is 2 and here is also 2, but we have to check the radicands. Therefore we can classify 64, we can further factorize it as 4 into 17, 17 fours are 68. Okay, we can return it as under root of 4 into under root of 17. Okay, if we will take 4 outside the sign of under root, then it will become 2 under root of 17. It further cannot be simplified. So 2 under root of 17 and 5 under root of 3 is totally different. The order is same, but the radicands are different. Therefore these are unlike surd. Why it is unlike surd? you have to write in word, that is the order of the surds are same but the radicands are different, therefore the pair of surd is a unlike surd. Next one, third example is 4 under root of 18 and 7 under root of 2. We will further classify 4 under root of 18. We will put 4 as it is. Under root of 18 can be classified 9 into 2. 9 2s are 18. So, I don't know you can see it or not. See, 4 into, we can write it as under root of 9 into under root of 2. If we remove the under root sign, 9 will be outside and it will be 3, because 3 3s are 3 3s are 9, so 4 3s are 12 or you can write 12 under root of 2. Here you can check out 7 under root of 2 and 12 under root of 2. The order of these two surds is same, as well as the radicands are also same, under root of 2 and under root of 2. Therefore, these are like surds. What are they? They are like surd because if we further factorized it, how we can 4 into 18 can be factorized as 9 into 2. We can write it as under root of 9 into under root of 2 separately. If 9 will come outside the under root sign, it will become 3. So 4 into 3 under root of 2. 4 3s are 12. 12 under root of 2. Here the order of these two surds is same, that is 2. And radicands are also same, that is under root of 2. Therefore, you have to write over here the order of these two surds is same and radicands are also same. Therefore, these are like surds. Now, this is the question number 3 from practice set 2.3. They have more 3 sub questions like you can see in your textbook page number 13. 19 under root of 12 and 6 under root of 3. Yes, this is a surd. If we further classified 19 under root of 12, it will become the order is same and radicand under root 3 will be the same. So it is a surd. Fifth is 5 under root of 22 and 7 under root of 33. 5 under root of 22 and 7 under root of 33 is not a surd because the radicand and order is same but radicands are not same. And sixth one, 5 under root of 5 and under root of 75. You can go for this, like these are the surds or like surds or unlike surds. Okay, you have to further simplify like this. If it will be the order became same, you know, if order is always same, you have to just go for the radicands. If radicands are the same, you can say it as a like surd. Okay, this is question number 3 from your practice set 2.3. Very simple it is. You have to just check the order. Please keep in mind we are learning the surds of order 2. Therefore, the order of a surd will be always 2. If they have not given the proper order, they have not mentioned the order, it will be always 2. And you have to just check for the radicands. To check the radicands, you have to you have to further factorize the number. There is always one surd which can be factorized, like we factorize here 52, again 68, under root of 68 and 4 under root of 18. Such numbers can be further classified, and by classifying it, whatever the answer comes, check it with the another remaining surd. If the radicands are the same, then it is said as like surds. If anything will be different, like order is not same, or either the radicands are not same, or both are not same, then it will be unlike surds. Next one is simplify the following surds. We will solve this question in the next video lecture. You have to solve question number 2 and question number 3 all in your notebook, and in the next video lecture we will solve the next questions. Keep studying. Take care of yourself. Thank you.